Quiz 3 solutions for Math 112. In this first problem, we're just asked to evaluate a whole bunch of logs, and I guess briefly show some work or somehow justify your answers. So the log base 5 of 25, you're supposed to figure out what that's equal to. Well, that's equal to 2. Why is that equal to 2? Well, because what the log base 5 of 25 is asking you is what power do you have to raise the base 5, in this case, up to make it equal to 25. And 5 to the second power is equal to 25. Therefore, the log base 5 of 25 is just 2. What about the log base 4 of 2? That'll end up being equal to 1/2. And the logic is kind of similar. It's again asking you what power do you have to raise 4 up to make it equal to 2. And 4 to the 1/2 power means the square root of 4, and the square root of 4 is equal to 2. What about the log base 2 of 4? Well, that's going to end up being equal to 2. The logic this time is we're taking this base of 2 and asking ourselves what power do we have to raise that up to make it equal to this 4 right here, and 2 to the second power equals 4. So log base 2 of 4 equals 2. What about the log base 3 of 1 divided by the square root of 3? Well, that's asking me what power do I have to raise 3 up to make it equal to 1 divided by the square root of 3. Well, to get the 3 down on the bottom, I'm going to want a negative exponent up here. 3 to the negative 1 power, though, would give me 1/3, and I don't want 1/3. I want 1 over the square root of 3. To get a square root out of an exponent, I need a 1/2 up here. 3 to the negative 1/2 power would be 1 over 3 to the 1/2 power, which is 1 divided by the square root of 3. So this answer is just negative 1/2. What about the log of 1/100th? Well, you need to know that the base here is 10. There's always an implied 10 when the log is not specified. So this is asking you what power do you have to raise 10 up to make it equal to 1 over 100? Well, 100 is 10 squared. So 10 to the negative 2 power would be 1 over 10 squared, which would leave us with this 100. What I'm trying to say is the answer here is negative 2. What about the natural log of 1? Well, that's 0. That's a pretty easy one. Any log of 1 equals 0, because no matter what the base is equal to, when you raise it to the 0 power, you're left with 1. So in this case, the base is e, and e to the 0 power equals 1. Thus, the natural log of 1 equals 0. Last one, log base 8 of 1/4. I think this is the hardest one on here, maybe. And you might not be able to do this in one step with this like because and then put the answer and write why. You might have to use our trick where we equate the bases. But what's going to end up happening here is we're going to want a negative answer because we're going to have to raise 8 up to a negative power if we want to turn it into 1/4. And then we got to ask ourselves, okay, what power must 8 be raised up to make it equal to 4? Well, the cubed root of 8 is 2, so I want a 3 down in the denominator, but I don't want 1/2 to be my answer. I want 1/4 to be my answer, so I'll end up with negative 2/3. If you follow that, great. If you don't, maybe I could talk you through it over here. 8 to the negative 2/3 power is the same as 1 over 8 to the positive 2/3 power. And then you need to know how to deal with these fractional exponents. And the way I think about it is I switch this from exponential form to radical form. So the 2 stays as the power, and the 3 becomes the root that I'm taking. So I want the cubed root of 8 squared. And the cubed root of 8 is 2, and 2 squared is 4. There's a long justification for why the log base 8 of 1/4 is negative 2/3. I thought that was pretty challenging. I think getting comfortable with logs is just one of the harder things in this class. So if you're able to follow that, that's really good. But if you weren't, don't feel too discouraged. We'll get there eventually. We'll get more practice with this stuff. The second question I hope was a little bit easier for you. I give you 3 log graphs, and all you got to do is figure out what are their 3 equations. And the trick for this is you can always figure out the base of the log if you figure out what x value corresponds with the y value of 1. So the fact that this graph in h goes through the point 10, 1 tells me that h of x must be the log base 10 of x, or just log x. What about g of x? Well, let's see when its height is equal to 1. Somewhere in here. It looks like a decimal. I'm not sure what that is. Maybe I'll put that on hold for a minute. What about the graph in red, f of x? That's got a height of 1 when x equals 2. What that tells me that f of x must be the log base 2 of x. But what about g of x? Kind of weird that this is a decimal in here. Let's go back to the problem. What's it say? Oh, there's a base that we've heard of in this class. Can you think of any numbers that you've heard of in this class that are decimals that lie somewhere in between 2 and 3? Looks like roughly, 2.7. Maybe you're thinking about e. If you are, that would be fantastic because that's the right answer. G of x is the log base e of x, which is a reminder we typically write that as the natural log of x. F, G, and H are log base 2, natural log, and log of x because they go through these 3 points. And so those would be the solutions, and that ends this quiz.